Semester Exam Review Packet, page number 4. Start out with identifying whether triangles are congruent or not. So we first need to identify, is there any other information that we can identify in the diagram? These two triangles are not connected to each other, so no, there will not be. If they don't touch, there won't be a connection. So I see that this has two sides and an angle, two sides and an angle. The only rule that allows two sides and an angle is side angle side. Is the angle included between those two sides? Is it where those two sides meet? No, the angle is not. Between the two sides, it is not the angle where they meet. So this actually fits angle side side, and since no donkeys are allowed, we say that we do not have enough information. And if there's not enough information, then we can't say that the triangles are congruent. Number 2, these triangles do touch each other, and because of that they share a side, and so I want to mark that with 3 tally marks because it is different than having side 1 or side 2. So now I see that I have 3 sides that are marked: side, second side, third side. And so these are congruent by side, side, side. All 3 sides are marked congruent to each other. So triangle KJH, K is the angle out here between the sides 1 and 2. Between sides 1 and 2 is angle G. So I use my triangle symbol, then G. J comes along the side with 1 tally mark, so along 1 tally mark goes to J also. And then down to H along this 3 means I finish up with H. In the third one, the triangles don't touch, so there's no additional information. I see that they each have 2 angles and a side. 2 angles and a side. So it's either angle side or angle angle. If the side is connecting the 2 angles together, it's between those 2 angles, therefore the angle, the side is in between the 2 angles, it is the included side. So angle is our reason. F is the start of the triangle listed, so F has 1 arc, so I put it next to, corresponding with J, which has the 1 arc. Next comes G, which doesn't have anything marked. K doesn't have anything marked, so K comes next. H has 2 arcs, L has 2 arcs. Triangle JKL. In number 4, the triangles touch each other. There are angles here that are congruent to each other, vertical angles. So I want to mark those on the diagram. And now I see that I have 2 sides and an angle. 2 sides and an angle in each triangle. And in both triangles, that angle is between those 2 sides. It's where those 2 sides meet each other. So this becomes side, angle, side. Side, angle, side. So triangle CAB, C corresponds with angle C. So I start my second triangle with C. A goes along the side with 1 tally mark. So with 1 tally mark, it takes me to D. And then finally it goes along the outside down to B. So I need to follow from D up to E. Conditional statements. If today is Monday, then tomorrow is Tuesday. Write the hypothesis. The hypothesis is the part of the sentence that comes right after the if, but does not include the word if. Today is Monday. That is the hypothesis. The conclusion comes after the then. So tomorrow is Tuesday does not include the word then, just the part of the end of the sentence, part that comes after the then. Write the converse. The converse is when we switch the if and the then, we switch the hypothesis and the conclusion around. So we keep if, but now instead of today is Monday, we start with tomorrow is Tuesday. If tomorrow is Tuesday, then, and now we use what was the hypothesis, becomes our new conclusion. Today is Monday. So if tomorrow is Tuesday, then today is Monday. Can this statement be written as a biconditional? Biconditional means that both the conditional statement and its converse are both true. If today is Monday, does tomorrow have to be Tuesday? Yes. If tomorrow is Tuesday, does today have to be Monday? Also true. So, yes, it can be written as a biconditional because the conditional statement and the converse are both true. Now I know it doesn't actually ask for this part, but the biconditional statement is where we write the if and only if. And so you can start with either the hypothesis or conclusion. It doesn't matter which one you use. Today is Monday, so we do not start it with the word if. It's just today is Monday, and now this is where we insert the if and only if, and then write the other part, in this case the conclusion, tomorrow is Tuesday. Today is Monday if and only if tomorrow is Tuesday. Or the other option would be tomorrow is Tuesday if and only if today is Monday. Either way would be fine. Alright, next column. So looking at this rectangular prism, we want to name a line that's parallel to line AB. Notice it has the arrows on either end of that line above the AB. So I want a line parallel to AB. So I see going the exact same direction could be FE. And that could be my answer. Now there's two others. You only need to list one. It just says name a line. But you could go AB is also parallel to CD. Or GH is the other one that's going in that same direction. All three of those are parallel to AB. Name A line skew to line FB that goes through point D. So FB is here in the sort of front left side of the box. And we need something that's skew, meaning it's not parallel, but it does not intersect FB. But it has to go through point D. So parallel would be DH. And so CD and AD, they both go through point D, but they do not intersect and they are not parallel with FB. So here our options are CD or the other one would be AD. So notice these will include the point D and will not include the letters F or B. in them. Name a line that is perpendicular to line HG. So HG is up here in the upper right side of the box. And we need a line perpendicular. So that means it has to intersect HG, not be parallel. So any of these sides, edges that meet HG, FG or GC, both of them will be perpendicular to GH. Or on the back side of the box, EH or HD, they both intersect at H, and so they are perpendicular. So if I was just to choose one, I could say FG is perpendicular to GH. Other options include GC, and on the back side of the box, EH intersects HG and it's perpendicular. Or the last one would be HD. So any one of those four would be perpendicular to HG. Name 4 coplanar points. So I need 4 points that are in the same plane. Now this would also mean, so in the rectangular prism we're just looking for 4 points that are on the same side of the box. Each side is its own plane, so we need the 4 points in that plane. So if I use sort of the front, a little bit to the left side, the points F, G, C, and B, they make up the 4 corners of that side, that plane. You could use any of the other 5 sides of the box and name the 4 corners of those sides, and those would work as coplanar points as well. If I'm going to name 4 points that are not coplanar, so typically I would choose 3 points that are in the same plane but are not collinear, not in the same line, such as F, G, and C. They're not in the same line, but they are in the same plane. And then I want to choose a 4th point that is not in that same side of the box, that's not in that plane. And so it could be H, or E, or A, or D. Any of those will work. I'll just choose H. But choose one that is not on the front side of the box. Number 13, last section here. Name a right angle in the diagram. Well, this little box in the corner, little square in the corner, tells us that is a 90-degree angle. It is a right angle. So angle 1, include the angle symbol for naming that angle. Name a linear pair of angles. So linear pair means that they are adjacent to each other and form a straight angle. So that could be angles 4 and 5 or angles 3 and 4. Angle 3 and angle 4, they make a linear pair, or angle 4 and angle 5. Put parentheses to group as just a second option. Name a pair of complementary angles. So complementary means they add up to 90 degrees, 2 angles that equal 90 degrees. So if angle 1 is a right angle, if it's 90 degrees, this straight line means that angles 2 and 3 also have to be 90 degrees. This line is perpendicular to the horizontal line. So angle 2 and angle 3 are complementary angles. They have to add up to 90 degrees. Name a pair of vertical angles. Vertical angles are formed when two lines intersect each other. This vertical line stops. It doesn't go all the way through, so we can't create vertical angles from there. The other two lines, the horizontal and this sort of diagonal, those two lines create angles 3 and 5. Those two lines are each part of forming those two angles. So angle 3 and angle 5 are vertical angles. A pair of supplementary angles means two angles that add up to 180 degrees. In a diagram like this, typically the easiest ones are to identify ones that form a linear pair. Linear pairs are always supplementary also. So we could say angle 3 and angle 4, or we could go with angle 4 and angle 5. Both of those are linear pairs, therefore they are supplementary to each other. And I don't see any others. So those are the only two options for supplementary angles in this diagram.